of learning Rust, and we will get started now. All right, Rustlings. So we have done 79 exercises so far, and we will be moving on to the next set of exercises. Let's see where we are right now. So we have to do threads. We finished smart pointers and iterators. Let's go to threads. Thread. Let's read the README on threads. So in most cat threads, in most current operating systems, an executed program's code is run in a process, and the operating system manages multiple processes at once. Within your program, you also have independent parts that run simultaneously, the features that can run independently. Dining philosopher's example. Using threads to run the code simultaneously. Further information using this. Let's look at this. Hmm. They don't have it. Okay. Right. Let's see if I can turn on the dark mode. Let's look at this one. Using threads to run the code simultaneously. Let me connect the chat. 1 second. Okay. All right. Race conditions where threads are accessing data or resources in an inconsistent order. Deadlocks where two threads are waiting for each other, preventing both threads from continuing. Bugs that only happen in certain situations and are hard to reproduce. And fixed reliability. Okay. Creating a new thread is, I think, thread spawn. Yeah, I think we did this when we were building an HTTP server. Mm-hmm. Mm. All right. Let's look at the exercise. This program spawns multiple threads that each set that each run for at least 250 milliseconds. Each thread returns how much time they took to complete. The program should wait until all the spawned threads have finished and should collect their returned values into a vector. Okay. Creates a new mutable vector here. Start time. Sleeps for 250 milliseconds. Print thread 1 is done. And then handle push. I'll be back in a minute. All right. I'm back. So what's going on here? So it is returning the how much time has elapsed for each thread, and that is what is being pushed into the handles. For handles, this. Collect the result of all threads into results vector. Use join handle. Okay, handle is a thread here, and this is a vector of threads. Use join handle struct, which is returned by thread spawn. No, let's look at the join handle. So I'm guessing this is you do handle dot join. Oh no, some threads. Join. Join button. So is it like merging the threads back into the main thread? Correct the result of threads into results vector, which is return join handle. Saving a join handle from to guarantee thread is run to completion. Okay, calling join on a handle blocks thread currently running until thread represented by the handle terminates. The two threads continue alternating, but the main waits because if the call does not end until the small thread is finished. It happens more. Mm-hmm. 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 Let's read up about the join once more. Waiting for all threads to finish using join handles. The code automatically stops the small thread prematurely most of the time due to main thread content, but because there is no guarantee on the order in which threads run, we also can't guarantee that the spawn thread will get to run at all. Okay, we can fix this problem of the spawn thread not running or ending initially by saving the return value of start spanning variable. The return type of join handle. A join handle is owned value that when we call the join method on it will wait for its thread to finish. Listing 6 show how join it's created in listing 16 to 1 can join to finish before main exits. Okay. We're splitting some value here. This is the main thread and this is the spawn thread. So it waits for main thread is like only 5 and spawn is 10. If we move it above, then it will wait for all the spawn threads to finish before it will start. So it will wait, it basically stops the execution of all the threads. Hey, hi, sorry, I am not able to read your name properly. Let me get here. Hexa, hexadecimal universe. Hey, thank you for the follow, and welcome to the chat. And also Mike Wo. Welcome to the stream. So we are doing rustling exercises and trying to learn Rust by these little exercises. If you're interested in Rust, or if there's anything you want to talk about it, anything you want to say, feel free to drop a message in the chat. Yeah, again, thank thanks for the follow. So we have finished threads 1. Now we will be moving on to threads 2. We learned that using the join on a thread makes all the threads finish themselves. Otherwise, like as the book says, we are not assured that all the spawn threads will complete their lifetimes. Threads 2. Okay. Building on the last exercise. We want all the threads to complete their work, but this time the spawn threads need to be in charge of updating a shared value. Job status. Okay, so a value is shared and these threads are talking to the same thing. Let's see. We have a struct and jobs done. Arc isn't enough if you want a mutable shared data. Arc. We learned this in the smart pointers when we were doing, right? Box. I think what we need is a cow. Yeah. I'll continue at reset. Yeah, let's look at cow control. Yeah, this is how you get a mutable shared value. I will uncomment this part. So I can have a mutable reference to cow from and a reference to that thing. Okay, so I think in the threads to here I need to convert this into a cow. And we do that by cow from. Mutable reference cow from. Let's see if we have any error messages. Oh, okay, we need to import this. We have an error. Do we need? Can I do this? Use traits. Oh, I have some errors with the cow. Cow is not implemented for job status. What if we stayed at arc? But I'm sure they want us to implement cow here. Let's look at the Rust docs on the cow. Rust cow. Rust cow for struct. Okay. An example of using cow with straw. We need to give them lifetimes. But what is this thing? We need to implement the two owned part for the struct. Create a container part that is such a slash. Let's see the error message that what do we need to do? Print the value of job status list. Status dot jobstring. Let's go with this for now, but we have to finish other things. Cannot assign. Trait deref mute is required to modify a dereference through a deref, but it is not implemented on arc. Yeah, this is what they said, that we cannot use arc. But how do I get a cow? But cows are not implemented for straw. And mistake action before you update a shared value. Is it enough? If you want a mutable reference. Now let's look at arc. You must take an action before you update a shared value. Any idea what I should do here? I'm kind of confused. It says arc isn't enough. Just give reference. Do I have to give it? Do I have to make it mutable? Mhm. Mhm. But it's got talking about immutable. What about mutable? Can I use RC? In this exercise, we want to express the concept of multiple owners. I think we can do rc.new. Standard rc standard. And then I can do, so now same thing can be owned by, it can have multiple owners, and then I can do rc clone of it and give it reference, pass around as reference. Okay, so here I could do rc clone. It does, is it not thread safe? Thread design a step, but indicating that they revolve around C, C thread, single threaded. Oh, it's single threaded. No, I need something that can have multi, that can work in multiple threads. If you need multi-threaded atomic reference counting, yeah, I cannot use RC. What about cow? Does it talk about cow? Mm, I'm sorry, Chad, but I'm feeling kind of stuck. This is not the cow I want. Uh, Using cows in Rust. Okay, let's look at this. Use cases for cow, understanding cow. Hmm. Yeah, but what about using cows in Rust code? Okay, let's say I have a dropped like this, and then we have to update the function which makes this approach unique for original strategy. The function will always clone the elements. How can I use but I want mutable. You can create an integer mutability. These concepts are foreign to me. I'm very new to them. Creates a hash set. No. All right, let's look at the hints. Yeah. We need to use another type that will only allow one thread to mutate the data at a time. So multiple threads have access, but only one can mutate at a time. All right. Fortunately, RT is like RCT, that is save things. Mutex. Mutex. Counter.lock dot unwrap. Okay, this is how I can do it. I think this is the solution. I need to lock it and then I can get the value inside. So thread no, standard status shared. Method not found in. Oh. Do I need to make it mutex? I think this needs to go inside the mutex. What is mutex? Let's look at what mutex. Mutex exclusion primitive is useful for protecting shared data. Yeah, this is what we need. Yeah. Unknown field. Dot unwrap. Okay, and U32 cannot be dereferenced. Okay. Yeah, I think we are close. Job's done. This is a mutex value, so this needs to be lock and unwrap status mutex. How do I get stuff out of mutex? I think this is how I can dereference it. Sorry. Left jobs equals to status dot log. Yes, this is done. Uh, okay, let's go back and let's rewind and learn the concepts that it wants to teach us. Arc itself is not enough to have mutable shared value. I think this is where mutex comes in. Uh, so we need to read about mutex. And then we have this part where we lock a thread and then fetch the value from the inside because this mutex will block the threads waiting for the lock to become available. The mutex can be created via. All right, so this is what allows us to have only one mutable owner at a time, despite having arc. All right, uh, that was good. Okay, do you have any questions you want to ask? Yeah, feel free to drop any questions if you have in the chat. Okay. Now, yeah, let's take a short break of like 5 minutes, and we'll start on threads, and then we will go to threads 3. Okay, let's look at threads 3, and we will start here. Yeah, let's take a short 5-minute break, and then we will start. We are back, and we just learned about arc and mutex. We learned that if we need shared one single shared reference to something, we can use mutex. Okay, that is thread safe as well because the mutex will block the threads waiting for the lock to become available. Okay, what is poisoning? This async programming thing is really difficult. It's not as easy as I had thought. Let's move on to threads 3 now. First, let's see the error messages. Use of the moved value tx. Move value used here after the move. Value was moved onto the closure on line number 22, but it was also accessed on 30. And we never returned the ownership. Okay, let's read the code. Let's check the hint. An alternate way to handle concurrency between threads is to use MPSC, multiple processor single consumer. Multiple processor MPS with both ascending end and receiving, and it is possible to send values in one thread and receive them in another. This is impossible by using clone to create duplicates of the original sending. Let's check this. Wait, one sec. All right, yeah. So this is interesting. Do not communicate by sharing memory, but instead share memory by communicating. To accomplish memory message sending concurrency, Rust sender library produces an implementation of the channels. I think this is a Golang thing. A channel is a general programming concept by which sending data is sent from one thread to another. A channel has two halves, a transmitter and a receiver. Transmitter half is the upstream location where you put the rubber ducks into the receiver. Okay. And receiver's end is where the end of the channel is said to be closed if either the transmitter or receiver half is dropped. Okay. Okay. So TX is transmitter and RX is receiver. Okay, let's go back and look at our code and try to understand what's going on. They have used MPSC here, which is a multiple producer, single consumer. Multiple producer, single consumer. Okay. We want to send TX to both threads, but currently it is moved into the first thread. How could you solve this problem? That's the problem. That's the only thing that I have to solve here. TX got consumed inside the first thread. That's why, let me turn on the line numbers for you. That's why line number 33 is not working, because it is consumed, moved in, but it was never moved out. Let's see if this documentation gives us anything. TX send dot unwrap, it was consumed, okay. And then you have a receiver. So here they're using TX only once. Pro channel and ownership transfer. I think this is what we need to learn. tx dot send val unwrap. This is what is happening here. Ownership, sending multiple values, seeing receiver value. Let's think about this for a second. Hmm. Let's look at the MPSC documentation and let's see if there is anything about Rust, about the sender. Sender, I can clone a sender. Yeah, what if I clone the senders instead of uh, instead of doing this? What if I cloned it and then sent it? I mean, yeah, I could do this. I could create a what this guy is suggesting here. Isn't that what I was trying? Unused variable. Let mute tx. But I cannot even clone it here because let's try to follow the messages here. Why? Why is that? Mm, Human value. Mm, No, this is not the correct way. Uh, why could I not clone? Could I pass a clone of the tx here, tx dot clone? Could I pass it like this? No, I could not. Let's look at this. So I have to create clones before I pass it on. Let mute tx2 equals to tx dot clone, and here I could do 1 cannot find value tx1. Okay, tx2. All right. So this is how you do it. And this doesn't have to be mutable, I'm guessing. JT, WT. Yeah, it doesn't have to be mutable. Let's learn about this once more. Passing data transfer between. So you use clones of the senders. This is multiple channels, multiple senders, and one consumer. Okay. So we can have multiple senders here. Yeah, but I want to see how other people have um, solved this problem. So let's go to GitHub topic rustlings. Let's see how other people have solved threads 3. Um, let's look at this guy's solution to threads 3 exercises. Threads. He only has threads 1. Okay. Uh, let's search the entire GitHub for threads 3. Threads 3 dot rs. When was this updated? Let's look at this one. He made clones of wait, wait. This is different than what I have. Line number 22. Send. Where is his send? He created a function and he's using Q, Q. Hmm. This is very different. Who is this guy? Some Chinese organization. Okay, never mind. Let's at let's look at this guy's solutions. So, exercise threads, threads, and he has made clones of everything. Why was there a need to make clone of Q1? Spawn for val and yeah, why was there a need to make a clone of Q? I don't get it. He made clones of the. Okay, never mind. We will take a look at one more solution. Yeah, this guy as well. He made clones of the. Anyways, I guess these guys are doing something else other than me. Yeah, so that marks the end of threads. We have finished threads, and I think in upcoming week we should be finished all of Rustlings. Not much is left, right?